So, 5 questions. Product expected from the reaction for upper left. I would immediately look for the most reactive thing. I see hydroxide is a minus, which then means I need to find a positive. The most positive thing I've got is that carbon. That can come in and attack. Okay, I'm doing a nucleophilic addition and an elimination. Okay, and I'd be kicking that structure out. Okay, since they're asking for the products, they're listing 2 in each case, so they actually want to know both pieces. One case that OH came in, and I'd have my CH3COOH. I'm trying to draw this fast. Okay, and as I scan through, of course they were dicks about this. And they didn't actually draw the formula or the structure. They gave me the formula, which means CH3COOH. Oh, they're all negative. Why are they all negative? That's an acid, and I'm in a basic environment, so I have to remove that hydrogen. I would eliminate A and B as answer choices because that has the 18 attached to them. The 18, according to my purple arrow, left. Okay. And we can come back to what that 18 means later. That then means I'd have to look at the other piece and try and decide what's going on with that. Well, crap. They're both 18. Well, I guess that makes sense. So it's in referencing now the stereo center. Okay. Well, where was the stereo center? Well, I go back. It's not that one. It's not that one. Well, oxygen can't be. It's not the carbon here. Oh, there's my stereo center. All my chemistry happened somewhere else, which means did the stereo center change? No. I started R, I end R, answer C. Using your knowledge of base strength, as soon as I see base, I'm going to immediately say electron donor, okay, or proton acceptor for that matter. I'm looking for a negative charge. Predict which of these reactions would be most likely to occur. Most likely means most stable product, okay, which would then mean least negative. So since I'm looking at bases, I need to be comparing this guy to this guy. Okay, and that first answer, I have resonance in the first one. And the reactant, that can't be my answer. Or I would immediately eliminate that and hope it was a straightforward question. Next one, chloride versus hydroxide. Also wrong, chloride's more stable. Okay, and I want the least negative in my product side. Multi-tiered, that's always fun. OCH3 versus that O-phenyl. This is interesting. I got resonance. Okay, resonance could stabilize that O-phenyl. Okay, so that's reasonable. So C is a possibility. If I move to D, D is irritating. I remember this question. Jerks. I'm looking for my most basic thing, which is going to be those 2 species. That's going to be misleading right out of the gate because neither of them are charged as a negative. So it's going to be coming down to which of those is more stable. Okay, so I go through with charge. Charge is irrelevant. I move to size. Sulfur's bigger than nitrogen. Sulfur's more stable, which then means it's the weaker base. It's on the left. D's wrong. My answer is C. Okay, 5. With 1 minute and a half left, 1 minute and 15 seconds. Which intermediate is involved in the mechanism of this base-promoted hydrolysis? Again, I see base. I think negative. Since I'm looking for an intermediate, I need to find negatively charged species. I have a negative here, but I have a positive. I don't like that. Not only is that positive, but that's a primary carbocation, so that's doubly awful. Okay. I have a negative that's good. I have another positive popping up. That one's at least resonance stabilized. I still don't like it because of the positive. Next one, I have a negative and no positives. That looks reasonable. Last one, I have a positive again. Don't like that. Answer C. And 30 seconds. What monomers are needed to produce this polymer? Recognizing where my bonds are going to cleave. Okay. I have 2 pieces coming in here, a dicarbonyl and the diol. A doesn't have a dicarbonyl, B doesn't have a dicarbonyl, C does, D does, and it has the diol, and I'm out of time. So. There's 1, 2 carbons in the diol in between. I have no carbons there. 1, 2 carbons, D is the answer. 5 minutes, 5 minutes, 10 seconds with explanations. Notice, did any of those that I just say what the answer was? No. I eliminated wrong ones. I addressed what I knew and worked with what I had, put that information down. Okay. For those of you who had me first semester, I yelled at you to do it in first semester. Those of you who haven't had me, I can start yelling at you now. Okay. Write stuff down. Okay. A base. Do you think I know what a base is? Why am I writing that information down? Because I know full well I'm an idiot and I will forget it. I'm writing it down so that way I can reference it. Instead of saying base means negative, all I look at is negative. Oh, I just have to find the negative. Okay? There's not a second layer of interpretation. And you may think, well, isn't that second layer of interpretation obvious? Maybe in the first half hour it's obvious. It's a 2-hour exam. Okay? If you write that information down, it will help you. Next big issue, those of you that have had me in first semester are aware of this. What's the issue with our ACS exam? You can't write on it. Okay? Which means you have to be taking careful notes as you go through and do this. I will provide tracing paper. I bought, I think, 1,000 pages of tracing paper. So everybody will have tracing paper. Everybody will have regular blank paper to take notes on. I will also provide a multiple choice, well, first off the Scantron, but then I will also provide just a questions 1 through 70 with A through D as answer choices so that you can go through and be like, this is my scratch paper. These answers I know are wrong for those questions. You've got that track record. So you could go through and say, those are wrong immediately, but I don't know how to tell the difference between the next two. I'm going to move on. If you then run into a time crunch at the end of the exam, you can come back and say, well, I had a choice between C and D. I'm going to guess C. Okay? Whereas if you came back at the end of the exam and you had no information written down, or you have A, B, C, and D, well, you're now at a 25% success rate as opposed to a 50% success rate. Okay? Make sense? Everybody getting an idea of what I've got drawn up there and how you should be processing? How many people got to the last one? Okay, 2 minutes starting now. So again, my processing, acid, I'm looking at H+, which means I need to see things that are positive. A is wrong, because I have that negative. B, reasonable. C, reasonable. Crap. D, reasonable. I had 3 positives outright. I need a little bit more information to go on. Okay. Hydrolysis means water. So I'm reacting water. What am I reacting water with? I'm reacting water with ethyl acetate. You might ask, well, how do we know that structure? Because that's nomenclature. You need to know that. Sorry. It's one of the things that's going to happen. You will get questions like this where you are responsible for the nomenclature to even get to the point where you can answer the question. Okay. So water, the oxygen's going to attack here, kick that out. Okay. So I'll end up with a tetrahedral intermediate with 3 oxygens. C's out. C had, at best, hydride attack. Where the heck did hydride come from? Hydride, hydro, there's your connection, just in case you were curious. Forming the carbocation, yes, that is positive, but how did that happen? I'd have to, at best, have a really, really good leaving group, and that's my abbreviation for really good leaving group, just in case you were curious. All I've got is an ethoxide. That's not a really good leaving group. Okay? So D doesn't really make any sense. That leaves me with only one answer choice, B, which, believe it or not, is kind of nice because what is the product of the very first step of the mechanism? B. very first step results in B. Right? So, I mean, they were kind of mean because they had a whole bunch of positive charged intermediates, okay? But B is actually, if you just did the mechanism, your very first result is B. Okay? Kind of makes sense? That is all I have from the ACS immediately on slides. And by from the ACS, just in case somebody comes back later and watches this and then freaks out, I'm posting ACS answers. These are not answers from the exams. These are from the test bank, or not the test bank, from the book. Okay, the study guide, okay, which I have 2 copies of. I have this really nasty one that I stole/borrowed from a colleague, which she stole/borrowed from a student. So I don't feel really all that bad. And then I have a much nicer, cleaner version as well. Okay. I'm going to try my best to be carrying them around with me at all times. Those are not bullet holes in the back, just in case you guys are curious. No, that's from biking. Okay? So, it's now up to you guys for questions. Okay, so if we take a look at this question, which is a little bit blurry there, but hopefully you guys have copies. We are trying to determine the product of this reaction sequence. So it's like a synthesis question. That very first thing drawn is what? It's a base. I would argue you should actually be adding a little bit more information to it than just base. It's a bulky base. Okay. Why the bulk? Well, the bulk means
it acts as a base.
It acts as a base, and only a base, which means, and we'll just pretend we didn't know who took the picture, okay, that we aren't going to see that nucleophilic attack, because that assumes it's acting as a nucleophile. Okay? So we aren't looking at nucleophilic attack here, we're looking at it acting as a base, so we need to find acidic hydrogens. Where are the acidic hydrogens? The alpha positions to our carbonyl. Okay. Which hydrogens? Doesn't matter at this point, they're identical. Okay? So if we remove one set away, we would end up with our nucleophile. What does that nucleophile then react with? We have a CH3Br. The bromine is a decent leaving group, making that carbon relatively positive. So we can have the electrons connect in, kick that out, and we'd have a methyl group attached on one side. Make sense? We then move on to step 3, which is another bulky base. Okay. Now we've got to be a little bit dicey here. Okay. Or at least now is when I would address an issue. Okay. For a couple reasons. What is the difference between these bulky bases? The LDA bulky base is using a negative nitrogen. The butoxide bulky base is using a negative oxygen. Okay. And that very first step, do I care?
No.
Why not? They're identical acidic hydrogens. So there is no relevance as to whether it's oxygen or nitrogen. In the second step, I now have 2 different alpha hydrogens to react. I can either react my red alpha hydrogen or my purple. Does that show up well enough? Okay. Well, which do I pull? So then the question is going to become why. I heard less sterics. Okay. Or the red one, which is still one with less sterics. So we're saying red because of less sterics. It's actually not a steric argument.
Substitution. Or not.
Well, H gets you more substituted pi bond. I said the purple one gets you more substituted.
Yeah, more substituted versus
Thermo versus kinetic, which is dictated based off of
Main H is less stable.
reversible versus irreversible.
Yeah.
Okay. This is going all the way back to that difference in our kinetic versus thermodynamic. We are using an irreversible base in the sodium, or sorry, the LDA, which then means I get the kinetic product, which means the double bond needs to form where it's lower instability. It's forming to the least sterically hindered side. I'm removing the red hydrogen. That means my nucleophile is now on the left-hand side. I can then react that with the next reagent, which is a propyl, and I'd be expecting a propyl chain down here, 1, 2, 3. Okay, so if we summarize that all out, right? And we compare that to our answers, and crap, that doesn't look like anything like our answers because sigma bond rotation. Okay? Not only sigma bond rotation, or is it just sigma bond rotation?
Just sigma bond rotation. They just flip the bond between
Oh, it is just sigma bond, yeah.
carbonyl and the alpha carbon.
And we end up with C. Make sense? Okay. So lots of things go into that. Probably the largest part of that is that last section, or the kind of intermediate section, the thermodynamic versus kinetic. Okay, we have to be very careful on deciding which hydrogen we remove. That depends on whether we have a kinetic or thermodynamic base. Okay? So we need to remember that. Questions on that? You good with it, Troy?
Yes.
Corey, you're next. What do you got?
The right on, B.
Troy? We can look for the very first thing. It looks like we're starting with a strong base, CH2, CH3. A strong base or a strong nucleophile. If it acted as a nucleophile, it could attack this position. We'd form our tetrahedral intermediate. We'd reform the carbonyl. And in the formation, the reformation of the carbonyl, sorry, I'll draw that a little bit lower. What do we end up with? The exact same thing. So that's not productive to have it act as a nucleophile, at least at that carbonyl. What if it attacked the other carbonyl? We would have a different structure. We'd have what compound, what functional group? No, sorry. The hemiacetal, what do we know about the hemiacetals?
They're not stable.
They're not stable. We reform the carbonyl. We kick out our leaving group. We go right back to where we started, meaning
That doesn't happen.
It acts as a base.
it's going to act only as a base.
We're very acidic hydrogen.
So we need to pull off the most acidic hydrogen, which will be
One between the two carbonyls.
the one between the two carbonyls. Why that one?
Resonance. Double resonance.
Right? And this is where I don't blame you if you look at it and you're like, I'm just not going to spend all the time on this. As soon as you draw that, you need to prove to me that that is an acidic hydrogen. How do you prove that? You need to show me the resonance. Okay. There's two of them. And yeah, could very well be where you're like, screw you, Mike, I'm not going to show that yet. I'm going to get what I can down first, and I'll worry about the resonance later. Okay. So now what?
Now, you have the next step,
We can move to step 2.
which is just a nucleophile.
Carbon electrophile.
It's a carbon electrophile. Iodine's a great leaving group. 1, 2, 3. That's not an oxygen. Sorry, I should not be drawing up there. Okay, I left that oxygen off. So far, so good. Okay, well, now what? We've killed the negative. We no longer have an electrophile. So we'd be moving into step 3. H3O plus and heat. This is where things would particularly get kind of irritating, I think, for this one.
So that makes the better makes the carbon better electrified.
3. Water can come in and attack. Again, we could show resonance. This would again be one of those cases of, you know what, I'll deal with it if I get time. Oxygen does not want to be positive. I'm definitely going to run out of space because I'm drawing way too big. I think if I remember correctly, people started frantically asking for scratch paper. So I hadn't fully processed how long this mechanism was.
You won't accept it if you just type resonance? Double arrow resonance?
Because yeah, I'm going to have to loop back on myself. Whoops. You ever feel like while you're drawing these kind of things, artist?
Do you feel like that?
Feel like drawing a happy little tree or something like that?
Secret shot, you good at that?
What? I was able to get mine to fit on a piece of paper in this space provided. Just saying.
Show off.
Well, you complain about how I write small. It comes in handy now. Oh, this is not organized. Look at all of this crap. It's not organized.
I'm going to be circling. Reconnect. Jerk. Whoa. Too far. Oh man. No, it's just adding crap to mine. The hell? Irritating. Be nice if I could just be like, copy and paste. Okay. And because I know where that next step is going, I'm actually going to redraw that. Why?
So you can see the, would you call it a coordination step?
It's the decarboxylation.
That's what you call it. Okay. Sorry, I asked you that this morning.
Those are all double-headed arrows. And I sure hope I haven't lost any carbons in the process of this. That'd be kind of irritating. CO2 should officially be drawn on there, but I wouldn't blame you if you didn't draw it. Probably wouldn't take off points either. Okay. We're still under an H+ environment. I might get lazy and actually do something like this. It's a bit dicey because I did 2 acid-base steps at the same time. We officially had a base come in here and remove that, and an acid. That's combining too many steps at the same time. But that would then get me to the final answer. And if you're very neat and organized like Jen, you can fit that all in one page or one little section. If you're not, you probably needed the whole page.
So you're not going to ask that, right?
Are you expected to be able to do it? Yes. As with all mechanisms, you could start into it and realize, oh crap, this is going to be really long. Draw a part of it, make me grade it, get some points. Partial credit is a lovely thing, get something down so I can give you points. With it being so long and so many steps, you're looking at kind of partial ideas all the way through. If you drew general concepts of what's happening all the way through to prove that you understood what was happening, but you're just like, you're a jerk, I don't want to write it all out, get a significant portion of the points. You write nothing, I can get anything. Does that make sense? Good. Just making sure I recorded that. Anybody have questions on that one? I know we had a loop. No? Next question?